All right, last night I suggested that you finish the parts 2 and 3. That's what I suggested. All right, again, I'm not coming around and checking that. That's what I suggested. This first part of the class, I'll ask you if you have any questions specific to parts 2 and 3. Again, do not ask questions because you didn't do it, and do not ask a question because you want to see if you got it right or wrong. I showed all that stuff on Aspen yesterday where you can go to figure that out. So is there anything? I have all the parts 2 and 3 up here done or cut out anyway. Anybody want to just couldn't figure out why yours didn't match the answer key? Maybe the video solutions weren't good enough either. We can talk. Again, what I recommend anytime you're doing a practice question, have those cold hard facts right next to you, because for instance, this circle question number 28, okay, you might have forgotten, but it's in the packet. So you don't have to guess. All right, it's in the packet. Whole times external equals whole times external. All right, so that's something you could have right by your side. Connor? Okay, hold on, check, hold on. Got it, 27.
You said yesterday that you don't have to have in a statement, you don't have to have the letters for a triangle to match up.
Correct.
Does that mean it's the same thing for this?
I know, we're not looking for it. Yep, we're looking for, did you translate, did you rotate, dilate, reflect? Okay, we don't care what the order is. Yep. Hi, Maggie. You could write in sentence form what you did, or you could also access, if you remember, we use these things called compositions. Okay, so what was this one? A translation. Well, you had to reflect over the y, right? Okay, so reflect over the y-axis, and then you translated it what? After I reflected over the y-axis. Okay, so here we go. 1, 2, 1, 2, and then you go right, 2, up, 1, 2, 3, 4, 5, 6, 7. That sound all right? Right, 2, up, 7. So you didn't have to reflect over the y-axis. Because B's got to match up with G. Okay, all right. So I reflected it over the y-axis. K's got to match up with L. So I did 1, 2, 1, 2. There's the reflection, and now I just had to go up 1, 2, 3, 4, 5. So Maggie, you could have also written it as a composition. And reviewing a composition, which one do you do first? One to the right first. You go right to left when you do these compositions. All right. If ever one, it will be on there. Anything else from parts 2 and 3? Parts 2 and 3 on here. Go in. Because I think over the weekend I suggested you finish the part 1s. Okay, I have a couple part 1s in store today, but as you know, next thing we go to now is your questions, topics that you want to cover at all. You got to start thinking about topics, all right? Because I don't think us just going through different problems will help. All right, you got to start thinking different topics through the year that you want me to refresh your memory with. Anybody have any of those topics? Meg? Law of signs. Sure. I'll go over the law of signs by doing going back to problem number 33. Okay, here we go. The question was law of signs. Can you review that? No problem. I will. Just let me, if I haven't stated it yet, all right, there should be no reason you need law of signs. Every single problem should be, you could use sine, cosine, tangent. Can you use law of signs? Absolutely. If you feel more comfortable using the law of signs versus using sine, cosine, tangent, go ahead. All right, nobody's going to penalize you for that. But there should be no problem on this Regents where you cannot use sine, cosine, tangent. So for this problem, we started out this problem by, well, we have to find the distance from C to T. but most of you guys found the distance from T to S using tangent, correct? Okay, well, I could have found this side using law of sines, or not law of sines, excuse me, adjacent, hypotenuse, so cosine. So I could have said the cosine of 72 is equal to 400 over x. All right, and this actually will tie into the problem Vincent had yesterday. So make sure my calculator's in degree mode. It is 400 divided by the cosine of 72. I'm looking at that side to be 1,294 and some decimals, which I'm not going to round because I'm not done with the darn problem. Okay, now if I'm going to use law of sines, I can use that triangle. I can if I'm going to use SOHCAHTOA. Why not? It's not a right triangle, but law of sines, you can use any darn triangle you want. It doesn't matter if it's right or not. So now I can use law of sines that says the following. Side y, the one I'm trying to find, across from that angle, which I can find pretty easily, subtract 72 from a $1.80, we get 108. So that'll be the sine of 108 equals 55, sine of 55, and that's across from this 1,294 that I just found. So that's the way to use law of sines on that problem. Good? Okay. And again, if you do use law of sines, all four values have to come from the same triangle. You cannot mix and match values from different triangles. All four values need to come from the same triangle. I heard a couple of people pipe up law of cosines. I wouldn't worry about it. It's just something extra you don't need. Okay, if you want to go into the exam with it, fine, but I'm not going to show it just because I think it's an extra thing to remember. It's a long formula, all right, which you're not going to need for the Regents. Okay, law of sines is helpful if you get stuck. That's why I like going over that one. Meg, you good? Yeah. Emma, what's your deal? Okay, everyone asked this year, and this is my response every year. The question was the proof at the end, could it be indirect? I have not seen an indirect proof in the last 4 years, but that does not mean it can't be. Everything is fair game, okay? Because I say that because I think it was 3 years ago, somebody asked, will halves of equal quantities be on there? Halves of equal quantities are equal, and I said, I've never seen it on there. That June, they had to use it in a proof. Okay, so I'm not, never say never. Okay, so does that mean we're going to go over an indirect proof now? Oh, right. Well, it's your call. This is all your show here, guys. So, all right, what? And then Caitlin's on deck. Sure, we can. Yes. What? Top. Okay, can I do the indirect first? What was your deal back there? Yes, okay, so here we go. So indirect, what was your topic, Maggie? Completing the square? Okay, so here's where the deal. Indirect, completing the square, which is in your packet, we can do, and then finding an angle. Okay, everyone good? Okay, we're rocking and rolling here. Whatever you want to write down, you write down. All right, do what you got to do because I'm going to have to, I don't have indirect proof in the Regents exams that you have, so we're going to have to go one we done earlier in the year. Back to Unit 5 for an indirect proof. Again, if you guys, I don't know what you've been doing with all your packets. All right, this is coming from Unit 5. We did indirect proofs in Unit 5. Okay, I'm going to do this one with you. Okay, here's our indirect proof. I'll give you, if you want to set it up, set it up. If not, hey, this is your, you take what you want from our review here. But don't distract other people. That's all I ask. My first question is going to be, and don't yell anything out yet, is how did I know this was indirect? out of the 8,000 proofs we've done this year. What's up, Sinead? How did I know this was an indirect proof? Proof statement. What are we trying to prove? Something's not happening. Yes, it automatically has to be done indirectly. And do not be afraid to speak up as far as topics goes. No topic will get turned away. All right. So again, the first question was answered. How do I know this is indirect? Because the proof statement's asking me to prove something's not happening. After the givens, what's our next step in an indirect? We are going to say something. We're going to assume something is true. What are we going to assume is true? Be careful here. Watch your mouth. The opposite of what? Proof statement. We are not doing the opposite of any of the givens. We are going to assume the opposite of the proof statement is true. So we're assuming angle A is congruent to angle C, which we can use just like at a given. Angle A, we can mark it on our diagram, congruent to angle C. Now our goal is to show this is false by proving the opposite of one of the givens. Which given do we probably want to prove the opposite of? The not one. All right, so I need your help right now, and this is where it becomes a regular proof now. Get me BD equal to BE. This is where it becomes a regular proof now. Can you get side BD congruent to side BE? How are we going to get there? Forget the indirect proof now. This is just back to good old geometry, statements, reasons. How do I get BD equal to BE? Meg. You're right, something, but it's not labeled probably because I don't want to use it. Right, because hey, if you get those vertical angles, I'm still up here though. I need these. Where are you going when you get these vertical angles? How? Still listening. Okay. Because these aren't isosceles, so I can't say the sides across are congruent. Katie, where are you going with this, by the way? Before I start writing down a bunch of reflexive stuff, where are you going? Why do you need that? What are you going to try to do? Okay, that's what I wanted to hear. We're going to prove triangles, specifically these overlapping ones. Right here, BD. Hey, why is this one a nice one to prove? What side does it have in it? BE is not a side, tough guy. Come on, you're better than that. One job. BD, there goes the class average. B, and then this one right here, because it's got BE in it. All right, they do overlap. So yes, Kate saw angle B is in both. Angle B congruent to itself. Reflexive. Are those triangles congruent or do we need more? Are they congruent or we need more? They're congruent. Triangle ABE. How many of you are still unhappy with me, what I told you yesterday about this? ABE congruent to who really cares? CBD. But we're perfectionists around here. We're honors, so we keep it all the same. Ooh, how about the reason? Because I see two angles and a side, so I could do angle side angle or angle angle side. I just got to figure out if that side's in between or not. Anybody remember the hint I gave you back in the day if you can't see it? Draw out one of the triangles. Emma, here you go. So here's B, if you have to. I know some of you are studs and you're better than this, whatever. All right. So I have angle B. I have what else labeled? BC. And I have angle C down there. It makes it very easy now that I drew it out. Angle, side angle. All right, let's pick this speed up now. Why did I want the triangles congruent? So I could say BD is equal to or congruent to BE. It's been a while, but just let it roll off the tongue like the good old days. CPCTC. Yep. We actually did it the other day with the rectangle, so who cares? Okay, what just happened there? Whoa. That can't, these two right here can't happen at the same time, so you just contradicted yourself. So is this assumption true or false? So if that's false, what's got to be true? Angle A not equal to angle C. And how did we end these? Assumption led to contradiction. IA contra AI. Is that bothering some of you? Good. Good. And then I heard also, where's your contradiction? What two steps are your contradictions in? The given one, the given, and step 5. We do not, this is not a contradiction here. That's what we needed to prove. All right, 1 and 5. If you don't put that, I don't think it matters anyway. Yeah. I did look for it though, because we go a step above here because we're in what class? Darn right. All right, darn right. That's why I had you put it in. Okay. Indirect. Who asked that one? Indirect. We good? Okay. If you guys need more, I got more for you. Unit 5 though, if you still have your packets. Okay. Unit 5. That's where all of them are. Circles. Go back to your Regents exam, June 2018. Here you go. Question 20. Question 20 of your June 2018 Regents. What's the equation of circle O? All right, I could care less about the multiple choices right now because this may be a part 2 question where you have to come up with the equation on your own. All right, so can we build the equation just by that graph? All right. Okay, a reminder, circle formula. X minus h all squared plus y minus k all squared equals r squared. When you write the formula for a equation of a circle. I'm not worried about the multiple choices yet. We'll get there. I just want to create it on our own right now. Okay, what are h and k? Those are the center of the circle. Figure out where the center is right there. 1, 2, 3, 4, 5, comma 2. All right, so what's in the first part here? X minus 5 all squared plus y minus 2. You just change the signs or change the signs. Equals, all right. Can you find the radius length? Radius length would be 4 units, but what's getting plugged in here then? 4 squared or 16. All right, here we go. So I need to find the multiple choice that breaks down to that equation. Any issues building that equation? Any issues? All right, here we go. So Maggie's question was, I got to complete the square. It's going to be on there. All right, it's a given every year. All right, completing the square to get the circle equation. So let's start with number 1. The number's already over the other side, and the x's and y's are already grouped for you. Done. Now you just have to complete the square. X squared plus 10x. How do you find that number you're going to add to it? For what value? Half your b value. So everyone take 10 divided by 2, square it. I'm going to end up getting 25. So plus 25 plus y squared plus 4y, half your b value squared, plus 4. Hey, you got to keep it balanced. What did you just add to the left side? 25 and 4. So I got to add it to the right side. All right, here we go. Right here. Now you got to factor. Make it look like the circle equation now. Anybody remember the quick way? So you don't have to figure out two numbers that multiply to 25 and add to 10. Whatever half your b value was. So the 10 was my b value, half of it, plus 5. Well, we know it's not going to be this one. All right, but let's just keep going. Maybe it'll give us some hints of maybe some other choices I can eliminate so I don't have to do this 4 times. What's going to go in here? Y plus 2 all squared. And what do you get on the right side here? What do we end up getting on the right side? Okay, 16. So let's discuss here. It gave me 16, which I needed. But it didn't. It gave me the wrong signs inside. So does that kind of lead us to what we think is the correct answer here? 2. Why? Because ready? Now you're going to take not half of positive 10, but half of negative 10. That'll give me minus 5. And then you're going to take half of negative 4, which will give you negative 2. And the negative 13 there gave us 16. So we know we're going to get a 16 there. So 2. All right. Maggie, you good there? And everyone else, we are. I'm telling you, it's on there. It's going to be on there. Even though I have zero knowledge of the questions, that's one thing I would bet. Completing the square, and don't get on me about going over what we can go. We have a lot of days left. Partitions, I can guarantee will be on there somewhere. Absolutely. Probably a density question too. And obviously there'll be a proof on part 4. That's a guarantee. All right. Kate, you ready? Yeah. Okay. Let me see if we have any here. And what's the deal over here? We just joined the FBI with those earbuds. Yeah. Unless you just joined the FBI, let's get those bad boys out. I think we're in the FBI now. You know what I'm saying, Colin? What's your prediction? Give me an honest prediction for the Regents exam. Don't you can get egotistical if you want, but just what are we shooting for?
Well, I'm shooting for 100.
Do you think that's obtainable?
Probably not.
Why is that?
Because I'm not good enough.
You don't think so, huh? Well, if you want a 100, what I talked to you guys yesterday, where you got to focus and kill it. Multiple choice. Yep. You got to take your time on the multiple choice. There's nothing there. All right, I'm just going to have to make one up, Kate. All right. You just want finding an angle, right? Okay. All right, you ready? Make up a acute angle for me. Give me a side length. Oh, actually, you're actually trying to find the angle, so why would I give you that? How about a side length? How about here? Let's find this angle to the nearest degree. All right, it's still the same. I still go from that angle and I label the 20 and the 13 as opposite, adjacent, and hypotenuse. So the 20 now would be acting as my opposite side. And how about the 13? That would be my adjacent side. So I could use, oh boy, O and A, SOHCAHTOA, tangent. Yep, all right, so let's set it up. Tangent of, what's your angle? X, opposite, 20 over 13. This is the only time you do not cross multiply. All right, you're not going to get anywhere by cross multiplying. If you're asked to find an angle using sine, cosine, or tangent, we solve for x by taking the inverse of whatever you chose to use, in this case, tangent. So we're going to go inverse tangent, 20 over 13. Make sure you're in degree mode. At this point, I'm wondering how many period 7 students are getting up and borrowing a calculator because they didn't do it at the beginning. They won't get one anyway, so it doesn't matter. 57 degrees. There we go. Now, we also talked earlier about law of sines. Could you do law of sines here? You could, but because you'll have 20 over sine x. What you would have to do, because the only other angle you have is 90, you'd have to do what to find the side across? Pythagorean theorem, if you wanted to use law of sines. All right. Good, Kate? Okay. Other topics? If not, we'll go back to the Regents exam. Any other topics here? Keep thinking about it, please, please. Everything is fair game. Nothing will get turned away. Anything else going you can think of, or we're going to go back to the Regents? Oh, boy. Yeah, Teddy. Well, some things may get turned away. This guy. You got it. HL proof for Teddy. Nothing is turned away. And if it turns out to be HL, we'll all thank you, Teddy. Right? Oh, there it is. Oh, boy. You wanted an HL proof, Teddy? You got it. I don't know. I'm hoping this comes out to be HL. We'll see. Okay, here you go. There it is, HL. I think. What are you chiming in about, Dan? You got a problem with this? I didn't think so. All right. You want me to get the picture back up? I didn't. All right. Anybody working on that fat head of Dan? Anybody? Still? You can do it? All right. EC over here, still in the Survivor game. I think she just something else to shove in your face. I don't know. Oh boy, I'm going to totally regret this. We get a fat head of Dan. We just put these bad boys side by side right there. Side by side. Me and you, Dan, side by side. All right. I don't know. I didn't make it. It was a family gift. So. All right, you ready, Teddy? Got it? Okay, well, first of all, we got to prove 1 congruent to 2. So probably I should prove what first? Triangles that contain angle 1 and 2. So hopefully these ones right here. Okay, let's prove those 2 congruent. All right, let's see what I was given. AE is perpendicular to BD, so I have a right angle. In my diagram, not in the proof yet. And then the same thing over here. I have BF, congruent to DE. We might have to do something with that because that's not a full side, right? And then AB, congruent to CD. Okay, so let me first show you, so I don't run out of time, why this is going to be an HL proof. Everyone's good on what I've labeled so far here. And then I've heard already people chime in. We're going to probably have to do what eventually? Subtraction. And that'll get me these 2 sides. Everyone agrees? Once I do subtraction and substitution. Is that right angle in between those 2? So it's not side angle side. But they are what type of triangles? They are right triangles. And what are the sides called across from the right angles? Those are the hypotenuse. And then you got your legs right here. So everyone see the HL working here. Everyone see the HL. Okay, what needs to go in the proof now? Well, we got to say the right angles. Don't forget about those. So angle AEB and angle DFC are right angles. Perpendicular lines form right angles. Now, since this is an HL proof, you do not have to tell me they're congruent. If you do, that's fine. Leave it. That's fine. It's a correct statement, but you just don't need it. We're not going to take off for that. You just need to say they're right angles there. All right, now we got to do the whole subtraction thing. Before I can subtract, though, I need 2 pairs to subtract, and I only have the 1 pair. What else needs to be said for me to subtract? EF, reflexive to itself. And now I can subtract and say BF minus EF equals DE minus EF. And don't forget, anytime we subtract or add, we follow it up with a substitution. To say BE and FD are congruent. All right, what else needs to be said here in an HL proof? Because you're not ready to say the triangles are congruent yet. There's something else that's specifically reserved for an HL proof I need to say. Connor? I need to say I have right triangles. Okay, I need to say I have right triangles before they're congruent. So I need to say triangle, what was that one? BEA. And triangle, what's the other one? CFD. Yep. Are right triangles. Anybody reason why? Dan.
Right triangles contain right angles.
Yes. I don't know. Contain's a pretty big word, so I'm just going to say have. All right. How's it been sitting in that with that crew all year, Dan?
I think I've kind of learned to tune them out.
Good for you. You want to give me tips on how to do that?
It just happens.
What? You got a problem with what I said? I didn't think so. And then angle 1 congruent to angle 2. CPCTC. Teddy, how about that HL proof? Does that satisfy your needs? Okay. And hey, you never know. HL definitely could be part of it. Okay. Okay. Whoa. What? Yeah, I don't know what you're doing either. We got 2 weeks before game day here. We go right up to the bell here, champ. Okay, Mr. 100. Okay. Any other topics here? Because let's try to get a couple multiple choice done then.
Not now, Al.
23. I'm surprised nobody asked this yet. Okay, here we go. It's not often I'm going to read it for you, but line segment CD is the altitude drawn to the hypotenuse. I see this set of words together. I already know what type of problem it is. I don't even have to look at the rest of the numbers. Altitude to the hypotenuse. We got ourselves a Hill-Sass problem on our hands. Anytime an altitude is drawn to the hypotenuse, Hills and Sass, we get it now. All right, so what's this diagram look like? The right triangle is EFC. The hypotenuse is EF. So E and F, make sure it goes on the hypotenuse. C must be the right angle. I have line segment CD. There's your altitude. And now we can label the lengths. EC is 10. EF, 24. And you're looking for ED. So we won the first part of the battle, which is we've said, hey, it's a Hill-Sass. Now we got to pick the correct one to use. Make it easy on yourselves. Is the altitude involved at all? No. So there goes one of them. It only can be a what type of question? Hills. It only can be hills. Okay, H and hills. Okay, but that hypotenuse is the one for the large right triangle. Because there's 3 hypotenusi in that diagram. You only want the one from the large right triangle, which we labeled as what? What do we label the hypotenuse of the large right triangle? 24 over, what's L? That is a leg from the large right triangle. There's one we've only labeled, that's 10. The legs and hills are the same. S for segment. There's 2 of them, ED and DF. And I know you're just going to pick X because it's labeled, but which one do I pick? What if this one was labeled as well? The one next to, adjacent to the leg we're using. So the segment next to 10, X. Now it's pretty easy. Once I identify it's a Hills or Sass and I know the parts, no big deal. 24X equals 100. And to the nearest 10th, ED, 4.2. All right. Okay. Think about the topics over the weekend you want to review. Think about the topics. 30 seconds, Teddy.